Hey, what's up, everybody? It is November 5th, 2019, which means we are ready for this week's TNT Tuesday. All right, so I know last week that was the end of our candy series, and I know you're looking at a PEZ dispenser now. The reason we're going to be taking a look at PEZ dispensers is because in Unit 6 with reverse engineering, there's a lot of us that go out there and we'll start pulling in, very cheap things in order to go out there and reverse engineer. Kids have a tendency going out and grabbing a PEZ dispenser. Why? Well, there's a lot of moving parts, it's very cheap, and there's candy involved, right? So we're going to be taking a look at the PEZ dispenser mainly for one particular part. There's two really tricky ones in there. We're going to be taking a look at one, and one that's absolutely terrifying. Nobody knows how to go out there and sort of create this. I think I have the key for you, and it's going to be really, really helping you out. So let's go ahead. Let's just take a look at the document camera. Let's just take a look at what we have. So in front of you, you have the Jurassic Park edition of the PEZ dispenser, and with the PEZ dispenser, as you all know, okay, we're going to be getting parts look like this. This is the housing. You see it has PEZ on the outside, but if you take a look at the housing, you've got something here that basically you can go out there and measure with dial calipers, and you can go out there and create this using Inventor. So nothing too crazy when it comes to the housing. Here's the magazine or the clip that holds all the PEZ candy inside of it. In that, you also have a spring. But once again, taking a look at this, we can go out there, measure everything that we could possibly need with dial calipers, and create that using Inventor. Obviously, the candy itself, okay, we don't have to take a look at that. Those are really pretty simple. But the two most difficult parts that we're going to have is going to be the topper on it. This is the dinosaur head. This is very organic. This is something that'd be very tricky to create with Inventor, but I think your kids might be able to hobble along and possibly use some decal to sort of prop them up on that one. So that one's difficult for sure, but this is the one we're really here to take a look at today, is this spring. Now, it's just not like your typical spring. If we were to take a look at this from the top, you can see the profile is sort of this round slot sort of profile, and then it acts like a spring for throughout the rest of it. So it's going to require a little bit of research and a little bit of measurement to go out there and get this. So here's what I have found. We found from center point to center point, this is a distance of like 0.28 to 0.3. The outside diameter of this spring on both ends is a diameter of 0.26. The actual spring diameter, the wire diameter that makes up the spring, has a diameter of 0.016. Okay, and then the fillet, since we're not going to actually create this out of round wire, we're going to go about this a different way. It's going to be square in the end. If we applied a fillet radius of 0.007 in the end, we can get it pretty round. It's not going to be a perfect round wire, but it's going to look pretty darn close. We have 18 turns that make up our spring revolutions in the actual coil, and then our actual spring length is like 3.73. So that's all the information that we need to know, and that was obviously just by taking the spring and using dial calipers and getting all the measurements that we need. So enough with the document camera. Let's just jump over into Inventor and let's show you how to create this. So when we go into Inventor, we're going to come out here and create a standard inch IPT. So let's go ahead and get started with that. I'm going to come out here, start a 2D sketch, and I'm picking on any work plane. All right, the first thing I'm going to do is come out here and use a 2-point center rectangle. Okay, and what I'm going to do is come out here and apply this dimension here. So the thickness of our spring, the diameter of the actual wire is 0.016. So we're going to go ahead and just apply that 0.016 height, okay, to this. Next thing I'm going to do is go ahead and apply a distance here of 0.5. Okay, you know what, I'm going to come back on that. I do want to scoot this over. Let's just go ahead and let's just apply a dimension here of like, I don't know, let's just say 0.1. Okay, now let's go ahead and apply that dimension here of 0.5. Okay, like so. All right, so once we have that, let's go ahead, let's finish the sketch. Now what I'm going to do is come here to my origin folder. I'm going to expand out on it. I'm going to come right in here to the origin. It's kind of hard to see. And I'm going to be finding the axis that's going to go vertical. So in this case, it's going to be the y-axis. I'll go ahead and turn that on. Okay, and now what we're going to do is come out here and use coil. Okay, obviously this is the profile. It has selected that. The red arrow, we need to come out here and select our vertical. Okay, so that vertical axis is going to be the axis of the dead center. I'm going to come out here to my coil size. I'm going to specify revolution and height. So the height on this is going to be 3.73. That's what I measured on the actual spring, and we said that there were 18 revolutions on that. I'm just double checking my numbers. Looks good. Now let's go ahead and say OK. So we can see it's this sort of pasta noodle looking thing so far. But what we're going to do is, all right, is we're going to come out here. We're going to find the plane here at the bottom. Okay, I'm going to right click on that and I'm going to turn this on with visibility. Now what I'm going to do is start a 2D sketch. I'm going to pick, hold, and drag by the border. I'm going to bring this where it's hovering above that sort of corkscrew. I'm going to go ahead and green check it. Now what I'm going to do is come in here. I'm going to come up here and I'm going to find slot. Now the slot that I'm going to be looking for is this center point slot. I'm going to start this from the origin. I'm going to bring this over, keep this horizontal to select half the major axis, and then come up here, all right, to specify that one. All right, so now I'm going to come out here, go to dimension. I'm going to specify what this diameter is. Okay, so in this case, if I can get select, there we go. All right, we can see that that diameter is 0.26. That's what I talked about earlier. All right, and then right here for our dimension, we're going to go center point to center point. I said earlier that is a distance of like 0.3. Okay, so that's going to be the outside of our spring. Now what I'm going to do is offset this in a distance of 0.016. That was the thickness of my spring. I'm going to go ahead and just finish the sketch. Okay, now this is definitely one of those really fun parts where you're not going to be able to see this sort of happen until the very last click, and you're about ready to see that here. So what we're going to do is come up here. We're going to go to extrude. It's not going to be a join. It's not going to be a cut, but instead it's going to be an intersect. Okay, so the distance I'm going to take this is going to be a distance of all. Okay, and then what I'm going to do is go ahead and just make sure, okay, that this goes down into the right direction. So I'm going to go ahead and select my profile, which is in this case. Okay, we have made sure that that went down, and we can already see the preview how that spring is actually looking. I'm going to go ahead and say okay. I'm going to come over here and just turn off those work planes just to make sure things kind of clean up here, not so busy. All right, and there we go. That is the spring we have for a PEZ. But when taking a look at that actual PEZ spring, it's a little bit rounded. All right, so what I'm going to do is I'm going to come up here, go to fillet, and what I'm going to do is I'm going to come around. I'm going to select all these edges here. Okay, and I'm just going to verify that my fillet radius, see if I can grab this back one here, that my fillet radius is a distance of 0.007. So I'm going to come in here to my radius. I'm going to change this to 0.007. Okay, once I've done that, I'm going to go ahead and say okay. Now there's a lot of geometry that it's going to be crunching here, and it might take just a second or two. Okay, but in the end, it's going to go ahead and round that over. It's not going to be a complete circle, but it is going to round those corners over and make it look more like the actual round spring that it is in real life. And there you go. Okay, that is a PEZ dispenser spring. So if we take a look at this, we can see the profile. Okay, it's going to be sort of that round slot sort of profile. If we look at this from the side, we can see how it does stair step all the way down. It is a true spring, and there you go. Okay, that is how you create a PEZ dispenser spring. A lot of great stuff in there. This is a great example where students can go out there and finally go out there and use extrude intersect. That's something we don't get to use all that much. We have the coil feature. And there's just a lot of construction there, and you know, there's just a lot of process there that they have to sort of comprehend and figure out. But it's a great example of students using Inventor in your class. So there you go. That is it for this week's TNT Tuesday. Have a great week.